Imagine a world where mirrors never get dirty. Now consider reality, where mirrors do get dirty. The end game is to maintain mirrors at maximum reflectivity, dramatically extend coating life, and avoid the pitfalls, expense, and downtime when removing and replacing mirrors for recoating. Don't let this be you. At Photonic Cleaning Technologies, your end game is our end game. Our First Contact family of designer polymers were developed to safely dissolve and encapsulate contaminants, then leave a pristine surface where the dry polymer film is removed. Using First Contact is as simple as apply, dry, and peel. Pour or spray on, allow solvents to evaporate, then remove the dry film. Our polymers have been used and are still in use at many meter class and large observatories and similar facilities around the world. Tests performed at the 10.4 meter GTC in the Canary Islands shows a dramatic improvement in reflectivity when a mirror segment covered in Saharan desert dust was cleaned using First Contact polymer. Reflectivity measurements after cleaning improved to almost new, with nearly a 10% improvement, and scattering was dramatically reduced. Only the existence of pinholes and microscratches stopped total reflectivity restoration. Just imagine the light gathering improvement if the entire mirror assembly was maintained like this segment. And let's not forget the myriad of smaller workhorse telescopes, systems used for near-Earth orbit object and orbital debris identifications, for missile tracking systems, and other important tasks. These systems, often a single mirror that is easily accessed, can benefit from a scheduled cleaning routine. Consider also the time and monetary savings realized if mirrors are maintained in place for years. Removal, movement, recoating, and reinstallation cycles can all be delayed or skipped. Wouldn't you like to spend fewer resources on maintenance and more on science and observing?